joint series. I'm specifically going to be looking at framing joints in this video. Now, again, just to recap here, there are three main categories of joints: carcass joints, widening joints, framing joints. This video is specifically looking at those framing joint applications. And when we're looking through the joints, we're going to be talking about what are their names, what might they also be known as, because some joints have multiple names that they are commonly referred to, and then how they can actually be used, and some of the advantages and disadvantages you might find with those particular processes. And that might actually have some impact on the selection of the joints that you're using for your project. So have a think about the possible disadvantages and advantages and how they would apply to your project. And then what you should be able to do is then get that information, take that off, and document that in your folio, and help you to come up with which of the timber joints is most suitable for each individual application in your specific project. So here we go. Probably one of the most famous framing joints, mostly because when we say frames, people think picture frames, and picture frames are typically made from the miter joint. Now, the miter joint, in a bit of a standard ballpark, uses the 45-degree angle, and you can see it's cut along the end grain there on both pieces, and then slots together nice and snug to create a really neat looking joint. Now, again, like I said, majority use is picture frames, but can be used for any box application. The problem with miter joints is that it's very difficult to actually glue and clamp them together. You need miter specific clamps. Otherwise, obviously, the joint is just going to slip and slide. You can offset that negative by reinforcing it with a dowel, with a domino, with a biscuit, or with some other sort of feather-like system to hold it in place and stop it from sliding around when the glue is still wet. Now, the key advantage here is that when you're finished with a miter joint, no end grain is visible. And if we're thinking about those high-level applications of furniture joinery, it's fairly uncommon that you would see very raw-looking end grain if you went into a timber furniture showroom. It's typically hidden or treated in a way to try and make it look as little like end grain as possible. And so when we're thinking about how could we apply the miter joint to your project, basically any opportunity you have to hide the end grain should be taken, and the miter joint is one key aspect for that. As I said, it's a fairly simple, straightforward cut. It can be cut using a miter box with a tenon saw, can be cut on a table saw with the help of your teacher, can also be cut on a drop saw if the piece of timber is the appropriate size and your hands are in a safe position. But fairly easy process to complete. It's just more the gluing that's challenging. And then if you get the angles off ever so slightly, just by 0.5 of a degree, because you're working with a frame, if each piece that you cut is 0.5 of a degree off, the possible compounded error then is 1 whole degree of error per corner. And if it's a 4-cornered box, then there's 4 degrees of error possible for the miter joint being used across your project. So it is one of those ones that can be difficult to get really accurate, really precise, but it's a neat looking joint when it's done properly. Now, these halving joints, lap joints, cross halvings, cross T, halving, corner, lap joints, there's a whole heap of different names. Essentially, how you can tell that these are different from other joints is the thickness of the timber is usually divided into 2 equal parts, which is where the halving concept comes from, and the pieces of timbers are literally lapped one over the other, which is where the lap aspect comes from. Now, you can see on the bottom there, I've got a T halving. When that joint is put together, it creates a T shape. The top one is a corner halving, so it creates just a corner when it's put together. But you can also have a cross halving joint, which is where you get one board and lay it over the other to create the full T or the full cross shape, X shape more so than a T shape, depending on how you've cut your joint. Now, these ones are really easy to mark out, super easy to actually produce. Tenon saw and a chisel, and away you go. No real stress at all. Generally speaking, if the timber's thick enough, they're nice and sturdy. But if you're working with really thin timber, it doesn't really work. Other problem with this particular one, because you're taking away the thickness of the timber, any materials that rely on the thickness for their strength, I'm particularly talking like manufactured boards here, chip boards that require the outer layer as part of their strength, plywood that has decorative outer layer and usually cheaper materials used on the center layers. Any of those sorts of materials, the manufactured boards, probably not suitable in this application because you're not going to get the strength you require and you're going to get your piece falling apart. Main uses here, if you're thinking that little rail that goes across the bottom of your chair, like a footrest sort of thing, if you've got one of those U-shaped frames, fairly common to see this as well, but you can also use it for picture frames and those sorts of things. Now you can increase the strength of this one by reinforcing it with a plug or a pin. What you do there is you get your drill a hole through, and then go and get yourself some dowel from the shop, or you can make your own plugs using a plug making kit and actually push it in. And by using contrasted timber, so feature timbers, you can actually really highlight this joint and the precision of this joint by using a light and dark contrasting of timbers. I've seen this used in a couple of projects before. It really looks quite special. Next one across is the dowel joint. Now the dowel joint we spoke about back in the widening section, and dowel is one of those ones that can be used in multiple applications. And again, when I say dowel, I'm also talking about domino, because dowel and domino work in the same way. Domino, remembering, is a proprietary owned concept owned by Festal, the brand, and until that patent expires, not many people are going to have access to a domino machine because it's quite expensive. However, because the dowel is so common, so readily available, and you can get it for quite cheap, there's jigs available, etc. We'll refer to it as the dowel joint, but you could substitute the dowels here for a domino. Super easy to mark out, super easy to prepare, and there are jigs available. If you're using dowels though, compared to the domino, the first pin is really easy to sort out. You can use a dowel spur-tipped drill bit to get your first hole in. But if you go ever so slightly off your original position, then you need to remark the second hole. And the way you remark the second hole is by using a dowel pin. So there's a bit of a cost in getting the materials right for a dowel. The tools to get the dowel right is something that can be a little bit costly, but it's proven to work, so it's definitely there. Comparison to that, if you're using the domino joint, you're really just relying on center marks, and the domino machine actually does the cutting for you and ensures everything lines up. So it's a little bit less likely to have those errors that you experience with the dowels. So for that reason, we've sort of moved away from dowels in our workshops and moved towards more use of the domino because of how much more accurate it is and how much more simple it is for marking out. But again, application is the same. These ones can be used for widening joints, tabletops, etc. They can be used for construction of frames. They could be used for the construction of chair frames as well, so like the back of a chair, the footrest of a chair. All of these could be done with the domino or dowel concept, and also any other sorts of boxes as well. Next up is the mortise and tenon. Now, the mortise and tenon works on a two-part process. The mortise, which you can see is the hole at one end, and the tenon, which is a bit like the tongue that sort of goes into the hole. They fit together. They really rely on a snug fit like most of our joinery. And if you have a loose fit, then you don't get the right amount of strength, and you also don't get a really neat looking joint. One of the benefits here is when you're cutting out the mortise, unless you've got access to a mortising machine, then you're actually cutting that out with a mortising chisel, which is usually a 6mm wide chisel. And chiseling can be a process that is a little bit messy if you're doing it for the first time. It's not as neat as some of the other joinery techniques. However, because of the way the mortise tenon works, you can actually work around that messiness, because when the second piece slots in and it's got that little collar around it, it actually hides any messy chisel work. So as long as you haven't gone outside of that collar line, then it's a fairly safe zone if you've made a little bit of a mess or if you've left your pencil markers there or things like that. But again, if your joint is a little bit loose, you lose the benefits of the mortise and tenon. These ones are really commonly used in chairs. If I'm thinking about the chair I'm sitting on right now, I'll just show you here. You would assume that in the rail here and in the back here, you would assume that there is a mortise and tenon sitting in there. And effectively, these circular pieces are mortise and tenon in as well, just using a round process like a dowel. So mortise and tenon, really high strength joint. But again, only suitable for solid timber. If we're looking at manufactured boards, you start taking away those surface layers, you remove a lot of the strength of those manufactured boards. So they're not really suited to these specific applications. The bridle joint is the next one coming up. This is a really cool joint because not many people know about it and probably don't think about it outside of it being a square shape. Like if you piece together those two bits, you can see on my screen, you're just going to get, a square 90-degree angle. But the benefit of the bridle joint is because of how much surface area there is in the whole bridle system, where it sort of, sorry, just turn around so you can see, so it sort of slots in. Once you've got that sorted, you can actually then get a plane and plane over the edges to round it. And the strength is still there for the majority of it. So as long as you don't cut all the bridle joint off, you could cut a fair chunk of it off and have a huge amount of strength still working there. Again, you can reinforce this with a plug or pin, stop it from slipping in and out. It works in a very similar way to the halving joints or the lap joints that we spoke about earlier. Again, that means it's only suitable for solid timber applications because you take away those surface layers of chipboard, surface layers of plywood, and you start getting into that territory where your timber's nowhere near as strong as it was designed to be. This one, particularly good for framing if you're going to be shaping. That's the end of the framing joints. That was a real quick overview. Next video up is carcass joinery. And again, a couple common joints coming through there, a couple new ones coming through as well. Look forward to seeing you in that video and good luck with your research. Thanks.